Here we go. Okay, so what is the day? Today is November 3rd, so 11/3. And it's right there. So first of all, polynomial just means like some kind of a function. It could be linear, it could be quadratic. However, the reason why we're using the word polynomial is because poly means many. So that means we're going to go beyond just linear and quadratic. We're going to get into exponents of 3 and 4. Now, the names for these things you've already seen before. This is an Algebra 1 concept. A lot of the stuff that we're dealing with in terms of the naming of these things you saw back in Algebra 1. The standard form of them will look a little bit different than what you saw in Algebra 1, but it still means the same things that we did. So I'm going to try to do some color coding with some things here, try to use some different colors and shades and stuff. So in terms of what we are looking for, we're going to be able to identify a polynomial function. And specifically today, I should mention, we're looking at third degree and fourth degree polynomials. So highest exponents of 3 and 4. So far, highest exponents we've seen have been 2. For quadratics, we're going to be looking at exponents of 3 and 4, at least for today. And you're also going to be able to graph polynomial functions using tables and end behaviors. Tables would just be plugging in for a value of x and getting a value of y, and then getting the general shape of the graph and graphing it, kind of like we do with polynomials, except these shapes look different. So some useful vocab would be x intercept and y-intercept. Let's see, here's the, do you have the notes yet? No? Okay, here you go. X-intercept and y-intercept, which you are familiar with those. And in terms of this particular graph, how many x-intercepts are on this graph?
2. Oh, wait,
3. Yeah, there are 3. There are 3 x-intercepts. We got this one right here. I'm just going to go ahead and draw all the way back here, and then right here as well. So I'm going to put little arrows on the ends. 1, 2, 3. Those are the x-intercepts. So there's an x-intercept at -3, there's an x-intercept at 1, and there's an x-intercept at +3. All right, we can just see that by looking at the graph. Now, if it's a function, there will be only one y-intercept. So as long as you have a function, there can only be one y-intercept. There can be multiple x-intercepts like we see here, but there's only going to ever be one y-intercept, which is this one right here. That's the y-intercept. Wherever it crosses the y-axis. So far, we haven't looked at anything new. Thank you. Everything that we've seen here, we've seen before. The shape of the graph, certainly new, certainly different. All right, now here's a new term for you. Turning point. Also known as a local minimum or a local maximum. And we're saying the words local because if you think about the words minimum and maximum, that refers to the highest or lowest point on a graph, right? But if you look at this graph here, we should put arrows at the ends down there and up here. If you look at this graph, is there actually a minimum value on this graph? No, because it just keeps going down forever, right? Is there a maximum value for this graph? No, because it just keeps going up forever. So there aren't actually any maximums or minimums. However, there is a local maximum and a local minimum, which would be at a place that we call the turning point. Does anybody think they know where those are? What's that? Yeah, like it basically looks like a vertex of a parabola, but it's not actually a parabola because it's within the greater function. So right here, where that goes up and turns around, it goes back down, that would be a local maximum right there. Or a turning point. So this would be known as a local max, which would be at the point, looks like -3 and just above 4 somewhere. We're not going to actually write in the coordinates of it, but that's where it would be. So a local maximum. So it's a maximum of that particular portion of that graph. And then the local minimum would be this one down here at the bottom of that parabola looking part of this overall graph. So here's a local minimum. So we're going to have a whole bunch of vocab, some of which you already know, some of which is relatively simple to understand, right? Local min, local max. That's not a terribly complicated concept. Let's see. The next thing. We want to talk about something called end behavior. So, listen up. What do you think end behavior refers to? So, on the ends, where does it go? Yeah, that kind of thing. So, here's an end here. Here's an end here. This end goes down forever on the on the y-axis, as x also goes down forever. Over here, the y goes up as x goes up forever. So end behavior, write that down, end behavior. And it will, let's see. Rises as, as x goes left or right, or falls as x goes left or right. So the end behavior can be described using those terms. It's either going to rise as x goes left or right, or it will fall as x goes left or right. So if we look at the left end here, is this rising or falling right here? Falling as x goes left. Okay, so falls on left. So falls on left. What would we write up here? Rise on the right. Yeah, rises on right. We're just describing what's happening. Like these are just descriptors of what's going on with this graph. Yes, you are learning. All right, now the last thing we're going to write in here is increasing or decreasing. Read from left to right. So there's certain parts of the graph that will be increasing and decreasing, and the way that you would decide if it's increasing or decreasing is opposite. This is not the same as end behavior. This is as you read the graph from left to right. So from this end right here, as it's falling on the left, to this local maximum, is that increasing or decreasing? If you're going left to right, is this going up or down? Up, so that would be increasing, right? So just on right here, I'm just going to write increasing right on that curve, increasing right there. And then between the local maximum and the local minimum, what's happening? It's decreasing. So right here, I'm going to say decreasing. And then from the local minimum to the other end as it's rising on the right, what's happening? It's increasing again, yeah. So we're basically just saying what it's doing. Is going up, is going down, then it goes back up again. On the left side, it's going down as x goes to the left. On the right side, y is going up as x goes to the right. We've got these points in the middle. This one is a maximum value of that certain portion of the graph. This is a minimum value of that certain portion of the graph. The graph crosses the x-axis in 3 different places. It crosses the y-axis in that one place right there. So that's everything we just described. So in terms of describing a graph, yes, there's a lot, but doing each individual part of the descriptors, not terribly challenging. You're basically saying what you're seeing. And we learned a little bit of vocab in terms of how to describe. So moving on here, this right here, this is the graph of a polynomial function. This one would have an exponent of 3, by the way. And we'll take a look at what that looks like later. So it says recall. So recall that a monomial, so this is algebra 1 stuff, that's why it says recall. Try to remember from algebra 1 that a monomial is a number, a variable, or the product of a number and one or more variables with whole number exponents. For example, 2 or 2x or 2x squared. That would be a monomial. Or 2x squared y. As long as it's only one term, without a plus or a minus after it, that is a monomial, mono meaning one, a single term. Everybody remember that from algebra 1-ish? Coming back a little bit. A polynomial could be a monomial by itself, or the sum of multiple monomials. So if you have like 3 terms, that would be a trinomial. You remember that? Like x squared plus 2x plus 1, the things we've just been graphing, the quadratics, a lot of those are quadratic trinomials because they had 3 terms. Some of them were quadratic binomials, which are 2 terms. So a polynomial function is a function of the form. This is where we get a little bit technical, right? Like this, what? So this is a sub n to the x times x to the n power plus a sub n minus 1 times x to the n minus 1. So basically what we're looking at, a sub n, those are your coefficients. Those are the numbers that are in front of x. X is your variable, and then n are the exponents. And the reason why the n and the n minus 1 are up here is because whenever you write a polynomial, you write them in decreasing order. So if the highest exponent is 4, then the next highest exponent would be 4 minus 1, which would be 3. And then 4 minus 2, which would be 2. And then 4 minus 3, which would be 1. And so it's just decreasing order of the exponents until you just get to x. And then plus a sub 0. A sub 0 is just a value of a number. Just some number. With no exponent or no variable at all. So we'll take a look at what that looks like. And like, by the way, a sub n, a sub n minus 1, those are just the order of your, they don't actually have to do with the exact numbers of your coefficients, but it's like the first coefficient, the second coefficient, the third, and so forth. All right, so here we go. Constant monomial. So the degree is 0, which makes it a constant. There is one term, so it is a monomial. So this is a constant monomial. It's a monomial because it's one term. It is constant because it doesn't have a variable. There's no variable at all. That's a constant term. If the degree is 1, that's linear. So like that would be a line on a graph, like 2x plus 4 or 5x minus 7. The highest exponent for x is 1, even though it's not shown, it is 1. 5x minus 7 would be a linear binomial because there's 2 terms. If the highest exponent is 2, that's a quadratic. F of x equals 2x squared plus x minus 9. This is a quadratic trinomial. We just got done seeing a whole bunch of stuff like that. If it is an exponent where the highest exponent is 3, that's what's known as a cubic graph. This right here, x to the third power minus x squared plus 3x, that is a cubic trinomial because once again, we have 3 terms. And then this is probably a new word because I think cubic was the highest we got to in algebra 1. After that, we just said like 4th degree polynomial and whatever. There actually is a name for 4th degree, and it is quartic. Highest exponent of 4 would be a quartic graph. Today, we're going to be focusing mostly on these two, cubics and quartics. What happens if the highest exponent is 3 or 4? There are 3 terms here, so that would also be a trinomial. Now, there could be, on a cubic, up to 4 terms. You could have an exponent of 3, an exponent of 2, an exponent of 1, and a constant term on the end. So you could have another number after the 3x here, like plus 4. So there could be 4 terms. There could be up to 5 terms on a quartic. You could have an exponent of 4, an exponent of 3, exponent of 2, exponent of 1, like this one here, and then the constant term as well. So this is just saying here, we could have 1, 2, 3, 4. There could be 5 terms in a quartic. There could be 1, 2, 3, 4 terms in a cubic. Quadratic, most amount of terms you can have are 3. A squared term, a regular value of x, and a regular number. Linear, 2 terms. And then constant, just 1, because it's just a number. Do these words look familiar at all? A little bit from algebra 1? Okay. Because you definitely learned these. You definitely had these types of examples in Algebra 1 as well. We did not see this stuff in the middle for standard form. But in terms of degrees, type, examples, we definitely did that in Algebra 1. Any questions so far? Okay. Use this reference as you're working through the assignment today if you need to. All right, flip the page over. Let's start taking a look at some things that we can know about the graphs before we even graph them. So, identifying polynomial functions. First of all, these are disqualifiers for something that is a polynomial function. Polynomial functions need to be what we would call continuous. So basically, there's like a flow to the graph, like it's going to keep going end to end forever. There's not going to be any weird breaks or things like that in the middle of them. So things that would cause weird breaks and things in the middle of a graph would be these four things here. If this stuff happens in a function, it could still be a function, it just means it wouldn't necessarily be a polynomial, then it can't be a polynomial. So if there is division by the variable, for example, if you have like 3 over x, something like that could not be a polynomial. Good luck. I hope it goes well. So if you end up with a variable on your denominator that doesn't divide out, if it divides out, well, maybe even not that way. If you have a variable in the denominator, it's not going to be a polynomial. If you have a variable raised to a negative number, it also will not be a polynomial.
Okay, it's time for our cross-country team.
Yay!
It's time to go to your competition. Make sure you go to the attendance office and sign out before you get on the bus. Thank you.
By the way, division by a variable, if you remember exponent rules from Algebra 1, division by the variable and a variable raised to a negative number, kind of the same thing. Because x to the negative 4 power, you can write that as a fraction, which is actually 1 over x to the power of 4. Negative exponents make fractions. So these two things are kind of the same thing. Negative exponents and dividing by a variable basically give you the same thing. If the variable is under the square root, that is another thing that would make it not a polynomial. For example, if you have, what was the example here? 3 times the square root of x. That would also not allow it to be a polynomial. Or if you have a variable as an exponent, like that would make it an exponential graph. For example, 4 to the power of x. So if any of those things happen, we no longer have a polynomial. We would still have a function, but we would not have a polynomial. So for A, B, C, and D, we are going to check against our disqualifiers to see if we have a function or not. If it is a function, then you're going to write it in standard form. You're going to state the degree and the type. And then you're going to state the leading coefficient. By the way, the leading coefficient is just the coefficient that has the variable with the biggest exponent. That's all that means. So, is there anything disqualifying about A? Are we dividing by a variable here on A? No. Do we have any negative exponents here with the variable? No. Is the variable under a square root? No. Is the variable an exponent here? No. Okay, so polynomial, good. So this one is a polynomial, so we're gonna say, yes, that is a polynomial. And to write this in standard form, we have to write it in decreasing order of the exponents. So we're gonna have to rearrange basically these first two terms. So we're gonna say f of x is equal to 5x to the third power minus 2x squared plus 8. So we've done that. What's the degree? The degree is, by the way, the single highest exponent. What is it? Degree is 3. Single highest exponent, 3. Degree, 3. When you have a degree of 3, what do we call it? Look at the first page. Cubic, yeah. So type cubic. Those two things go hand in hand. The type and the degree relate to the exact same thing. So you just find the degree and the type, look at the same line on that first page if you need to double check it. That's what you can write in for those. And then the lead coefficient, we can just say LC for lead coefficient. What is the first coefficient when we wrote this in standard form? What number is in front of the x to the third power? 5. So that's it. Coefficient, number next to a variable. The one that's in front of the highest degree variable is 5. So that's it for that one. All right. For B, is anything being divided by a variable here? Or is a variable being divided? Or is there variable division here? I don't see it. What about a negative variable raised to a negative exponent? I don't see any negative exponents. Is the variable under a square root on this one? One second. Is the variable now under a square root? Was it under a square root? The square root did not extend over the variable and the exponent. Therefore, the only thing under the square root here is 2. Because this square root does not extend over the top of the x to the 4th power, that x to the 4th power is not under a square root. And by the way, even if it was, this would still be a polynomial. Because the square root of x to the 4th power, even if it was, the square root of x to the 4th power is equal to x squared. So it does simplify to that. So, but even still, this is okay. A number under a square root is fine. A variable under a square root is not. So there's a distinction there. Is there any variable here that is an exponent? I don't see any variables that are exponents. So here we go. Yes, this is a polynomial. In terms of our standard form, we're going to say g of x. We have to rearrange the 3rd and the 4th degree ones here. So that would be equal to the square root of 2 times x to the power of 4. Make sure that that square root of 2 does not extend over x to the 4th power. Minus 0.8 x to the 3rd power minus 12. All right, what is the degree? 4. What is the type? Quartic. What is the lead coefficient? Square root of 2. There you go. All right. C. Is that a polynomial? No. Why not? Why is C not a polynomial? Yeah, there's a negative exponent right here. So, nope. All right. Every time I hear the word nope, this is a side note, and it's going to sound really weird because it is. I saw a video on Instagram, which probably means it's on TikTok. I'm old, so I watch TikTok videos on Instagram. So it works. But there's this like really weird advertisement for some guy who does taxidermy. Chuck Testa taxidermy. He's like, nope, it's so weird. Look it up. It's fantastic. It's hilarious. So if you know about taxidermy or anything like that, you probably find it super funny. Even if you don't, just the way he talks is great. So, all right. D. Polynomial? No, why not? Variables and exponent, can't have that. All right. So usually the negative answers on these are usually easier than the affirmative answers because there's a lot less work to do. You say, no, not a polynomial. These ones, if it is a polynomial, you got some extra stuff that you have to write in. Degree, type, lead coefficient, all that stuff. All right. Don't worry about this one here. Write your own example. Don't worry about that. Let's move on to evaluating. Now, here's something that should be pretty darn simple because you don't actually need to do the math. You just need to type it into your calculator correctly. And that calculator could be the graphing or the scientific. Either way, it doesn't matter. Evaluate f of x equals 2x to the fourth minus 8x squared plus 5x minus 7 when x equals -1. Basically, everywhere you see x, put a -1 in. That's it. It's just like finding a point on a graph. Actually, not like. It is finding a point on a graph. So we're going to write f of 1, because x is 1, equals 2, and then times 1 to the fourth power minus 8 times 1 squared plus 5 times 1 minus 7. Except it's not 1, it's -1. So let me change that. And over here as well, f of -1. So basically, you're finding a point on a graph. When x is -1, what does y equal? So you just figure it out. You can do that using mental math if you want to, or you can type it into your calculator. It doesn't matter. But that's what I got. -18. And you can literally type this exactly like this into your calculators. By the way, something I noticed on the test as I was looking through a few people's tests, when you square a negative number on a calculator, I'm talking about b squared underneath your discriminant, like on the discriminant, when you square a negative number on your calculator, please, oh please, do not do this. That will not give you the number you need. That is the opposite of 8 squared. That is not -8 squared. -8 squared is 64. The opposite of 8 squared is -64. If you typed in your b squareds, if b was a negative number and you didn't use parentheses on your calculator, it's not going to get you the right answer. You must use parentheses around a negative number when you square it if you want to get the correct answer from that. So if you need to drop by for TAT today to double check those, I would recommend it. Make sure you're doing that if you square a negative number on your calculator. All right, let's move on to this one. Actually, do that one on your own. Do that one on your own. Evaluate g of x when x equals -4. I'm not going to give too much time for this. Anybody have an answer yet? I got 121. Yeah. Positive 121. When you type this into your calculator, the reason why, by the way, I use parentheses when I write this on my paper is because that's exactly how I type that in on the calculator. The negative needs to be there, and you have to have a negative on the inside of the parentheses. So the opposite of x to the third power would be the opposite of -4 to the third power. So that's an important part of that. Okay. Any questions here before we move on? Cool. So evaluating, just plug in and solve. That's all that means. Bless you. Okay. Next page. This looks pretty complicated. It's really not that bad. This is talking about end behavior. So we're talking about what's going on with the end of these polynomials when we have certain exponents and certain values of a. Certain values of a meaning, is the lead coefficient positive or negative, that kind of thing. All right. So over to the left right here, when you see the word, when you see f of x arrow to the right plus infinity, or x arrow to the right negative infinity, that kind of thing, what this is saying is right here, the expression x with the arrow to the right plus infinity means as x approaches positive infinity. So that means on the graph, as x goes right. I guess for you it would be that way. As x goes to the right, so as x approaches positive infinity, because that's positive infinity on the x-axis. So what we're saying here on the right side, as x approaches positive infinity, then f of x also approaches positive infinity. F of x is the same as y. So that would be y approaches positive infinity. So y approaches positive infinity. F of x and y, remember those two things are relatively interchangeable. F of x represents the y value. X represents the x value. So as x goes positive forever, y goes positive forever. Over here, as x goes negative forever, y goes negative forever. That's what that means. We would say right here, we can just use the words down on left. Over here, up on right. Right here, we would say up on left. And then over here, down on right. I'll talk about the shapes of the graphs in just a second. Over here, this would be up on left. And over here would be up on right. Over here, down on left and down on right. So we're just talking about the symbols and what they mean. So as x goes to negative infinity, like this last one here, as x goes to negative infinity, so as x goes left, the y values f of x also go down forever. Negative infinity and positive infinity. So end behaviors always go to infinity. Question, Mary? No, it was -4 all the way through. Yeah, right here. So did you have a negative on the outside of the first parenthesis and a negative on the inside? Okay. All right. So head back here real quick. I want you to notice here, by the way, we're talking about in general odd degrees and even degrees. However, these are specifically, these are both cubic and those are both quartic. However, the end behavior is true for all odd functions and all even functions. By odd, I mean the highest degree, the highest exponent is an odd number. That's what that means. So like x to the third power is the highest exponent, or x to the fifth power is the highest exponent. Down here, be even numbers, like quadratics, for example. Quadratics are even numbers because its highest number is squared. However, these are not quadratics, those are quartics because they have the bumps in the middle. But the end behavior still works the same. So if you have an odd degree as your highest exponent, the ends will go in opposite directions. If you have even exponents as the highest exponent, they're both going to go in the same direction. The ends will either both go up or both go down. Quadratics are a perfect example of that. And even a linear equation. Think about a linear equation, right? The ends go in opposite directions with lines. If the exponent's 1, they're still going in opposite directions. Quadratics, up or down, right? Both up or both down. So that's what we're dealing with there. Now, if we're talking about a lead coefficient that is positive, so the number in front of the highest exponent is positive, then it will be like this. It'll go down on the left and up on the right. If it's negative for an odd function, it'll go up on the left and down on the right. And then these ones here, this is like our positive or negative value of a for quadratics. If it's positive, both ends go up. If it's an even function, if it's negative, both ends go down. That's just what we know that from quadratics. And the same is true of every even exponent beyond 2 as well. So that's what we've got. All right, so let's go ahead and do some translation real quick. Find these symbols up top and tell me what we wrote next to them. So as f of x goes to, so as y goes to negative infinity, x goes to negative infinity. What did we write when they both go to negative infinity? What were the words? We wrote 3 words. Down on left, exactly. So down on left. All right, how about the next one? Plus plus. If they both go positive, what did we write? Up on right. There you go. So we're just doing some translation. F of x is negative, x is positive. F of x is negative, x is positive. That would be down on right. Down on right. And then, how about this one? Up on left, yeah. Y goes up, x goes negative. So that would be up on left. All right. Now we're going to move on to some descriptions of end behavior. We might be able to finish with a little bit of graphs. We might pick that up on Monday. We'll see what happens. So here we go. Describing end behavior. So is this an even or an odd function? Is the highest exponent an even or an odd number? 4 is even. Yeah. So that's even, which means both ends are doing the same thing. They're either both going up or both going down. That's what an even function does. Is the lead coefficient positive or negative? Negative, yeah. Lead coefficient is negative. What does that tell us about the end behavior? Down on left, okay. And then what about the right? Down as well. Okay, there we go. Down on left. Down on right. Down on left, down on right for A. I'm going to move back for just a second, but what we're looking at is here. It was an even degree. Lead coefficient was negative, so you can just go straight to that diagram and write what we wrote on both sides for the end behavior. Down on left, down on right. Okay, let's keep going. So basically we created a chart and you're just referring to the chart based on what we see. Highest exponent, odd or even? Odd. Lead coefficient, positive or negative? Positive. If you want to do a plus for positive, that's fine. Minus for negative, I'm cool with that. So find the odd with a lead coefficient positive. Give me the two phrases we have. Down on left, up on right. You got it. Is this the most difficult thing you've ever done? Probably not, right? Odd or even? Odd. Lead coefficient positive or negative? Negative. What are our words? Up on left, down on right. Nice. So far, we haven't graphed a single thing until, flip it over. Here we go. We got some graphs. So, in terms of working through this, we should have an idea now, in general, like rough idea, about what some of these things could look like. Let's skip A. We don't need to worry about that one. I want to make sure we've got time to do B. So, odd or even? Even. And lead coefficient positive or negative? Positive. So that means it's going up on the left and up on the right. In general, we know that's happening. Now, just like every other graph you've ever put on a piece of paper, the y-intercept is still this number here on the end. So what's the y-intercept? 4. All right. So go up to 4 and put a point. We'll start there. Great. Now, we could make this more challenging than it needs to be. And we could talk a little bit about, like, making a table of values and figuring things out. Or we could go to our graphing calculator. And we can find some nice numbers on our graphing calculator when we graph it. So let's do that. So go to y equals, type it in. X to the power of 4. Oh, by the way, if you want something other than a second degree exponent, push the button above divide. That is the exponent button, and you can type in whatever number you want. So x to the power 4. In order to get back down, though, you have to push the right arrow to get it back down here. So x to the 4th power minus x to the 3rd power, head back down, minus 4x squared plus 4.
Friday, November 3rd, 2023. Don't forget there's a wrestling meet
Standard.
today in room 216.
There we go.
Pizza will be provided. They're going to discuss what practices will be like.
Look at that thing.
Basic introduction to the wrestling season.
All right.
Meetings for all wrestlers currently on the team, as well as those who are interested in joining the team. Students, do you need some college rule?
Go to your table of values.
This is a very large
Second
slide
graph.
for the school for your use. Please stop by the
Ooh,
office.
I do
and
not
ask
want
for
that.
some.
1.
And the art club is.
Oh, that's
sponsoring
terrible. Why are we doing this?
Party
Oh,
Friday, lunch. Please bring your lunch, your friends, and your creativity to Miss Johnson's room. That's room 311. We hope to see you there. And don't forget, this upcoming weekend is the end of daylight savings time for the year. Our Sunday morning, on Sunday morning, we will set our clocks back an hour and get an extra hour of sleep. You can do that.
It's not good. I want.
Seniors, there'll be a cherry packing party
Oh my
this
God.
Sunday at the middle school from 1 p.m. to 9 p.m. Must have a lot of cherries to get ready to sell.
Hang on.
And juniors and seniors, next Monday.
terrible.
We'll be giving the ASVAB career test in the Career Center at 8 a.m. This is your last chance to sign up if you want to participate. If you'd like to take the test, go to the counseling office today and get your name on the list. Seniors, on Monday, the University of Oregon will be here to hold an application workshop at 9 o'clock in the Aspire room. If you attend this workshop, your application will be considered for early action. And then we have FAFSA and ORSA account workshop for seniors and their parents on Tuesday, November 7th, 5:30 to 7 p.m. in the Career Center.
If your table was actually good, unlike mine, use your table.
Congratulations to all of our fall sports teams on their great seasons they've had.
Go to your
Updates
calc
on
menu,
teams still in the
second.
race for seat.
Trace to go to your
4A volleyball
calculation.
tournament will take place at Springfield High School today and tomorrow.
Let's look for our zeros first.
Northfield
X
at
intercepts.
15 p.m. in the first round of a double elimination
So it
tournament.
says left bound.
Girls soccer team
So-
makes it to the second round after their win on Tuesday
Go there.
against Newport. They will travel to
And
Woodland
there.
High School to take on North Marion at noon tomorrow.
There we go.
And the boys and girls cross country teams are just about ready to
Interceptor one.
It'll be the state cross country championship race.
So over here.
at Wayne Community College tomorrow. Our
X
girls
interceptor
team
one.
competes at 11:45 a.m. and our boys team competes at 12.
We have another X intercept over here, so let's figure that one out. So calculate.
Second round after their win on Wednesday against Pendleton. They will have a home game.
Yeah.
Talking soccer field against Crook County at 2:30 p.m. tomorrow. Admission is free if you have an ASB, or it's $10 for adults and $6 for students. And if you're in the play, the rehearsal for today has
zero.
been canceled. Rehearsals for tomorrow, however, are still on, so please be here in the morning at 9 a.m. for the playground. And the joke of the day.
2.38-ish.
Leaping turkeys. Wobble, wobble, wobble.
That's about
Have a
right.
great day and a great weekend.
So let's get the rest of this graph on here real quick so you can see what to do. So hang on, we still got a couple minutes. We got 3 minutes. Daniel, go to class. Or wait outside. We're still working. Go outside. All right. Go. Seriously, go. We got work to do in here. All right. So we still need to figure out our local minimums. There are two local minimums. We have our local maximum here because that was the y-intercept. We have our two x-intercepts here. So for the calculations, just find minimum. And then find your local minimum. It says left bound. So go to the left of this local minimum, hit enter. Go to the right of the local minimum, hit enter, and then it'll find it. And that's at negative 1.95. So negative 1 up 1.95, that's about right there. So we're just getting our local mins, local maxes, x-intercepts, y-intercepts, and then the final local minimum is going to be down here. Our left bound is here. Our right bound is here. That's 1.8, negative 4.3. So 1.8 is about here, and then negative 1, 2, 3, 4.3 is about right there. So here are the points that we're using. We know that it's coming in from the top over here, so we're going to say, all right, it's going to look about like this, and then it's going to curl around and go up and then back down. Really far down there and then back up this way. And it'll look about like that. Now, obviously, that's not a great looking graph. It's a little bit hard to get them perfect because you're not going to, but in general, put it on your graph, figure out the x-intercepts, figure out the y-intercept, figure out your local and mins and maxes, and that will give you the general shape of your graph. All right. I will post the assignment on Google Classroom very soon. There is an assignment from your book. I will put it on Google Classroom. It will be there. We'll take a look at it on Monday. What's that? Yeah, if you're done with your test, I will have those in the gradebook today. Yeah. Abel, are you still working or are you done? Still working, so TAT. Okay. If you want to wait till Monday for lessons here, you can come in during TAT.
Main office that has lost and found clothes and water bottles, check it out because that stuff will be disposed of if it's not.
Have a great weekend, everybody. See you on Monday. There you go, all those words mean. You too. See you Monday. Hey. Welcome back.
I was on yesterday.
Yes, you were. We will get you started on the test today. We're taking the first 20 minutes of class today to keep working on the test. And then we got a lesson after that. And if you can make TAT, come for TAT as well. Gotta keep working. Yeah. Oh, I hear you. Been there. All right. Yes. Those are cruises. Thanks. Marcos. Yes. Okay. No, you're both gone. And I also said that it could be a partner test too. So if you want to work with somebody else. Yeah. That's a good question. Yeah, that's the cross country team. There they go. Why didn't they just have them run to Eugene? They're the cross country team. Run a, nice 150 miles or whatever.